There's something I love about cars. Apart from the body make I love the tires. So this video is going to tell us about the forces acting on a car tire, how they interact to make the tire move or is stationary. All type of cars with various bodies have tires of various kinds. All tires are made of rubber, not plastic. There's a difference between rubber and plastic. The bucket you use in your bathing room is plastic. If you want to know more about that, click the follow button and the subscribe button so you will be updated when I make a video on that. Now back to the tires. There are forces acting on the tires of all vehicles, and these forces can be used to predict the direction of movement of this vehicle. We have the normal force N shown by the red arrow pointing upwards. We also have the tractive force T shown by the green arrow pointing forward. We have the frictional force F prime shown by the pink color arrow pointing backwards to the tractive force, and we have the rolling resistance which is on the tire. So let's see how these forces interact. The normal force N is the force exerted by the ground on the tire. It is perpendicular to the surface, that is 90 degrees to the surface. The surface is the white line we are seeing. Now this force supports the vehicle's weight and maintain contact with the road. The frictional force acts to oppose. You can see the arrow pointing backwards. It is the force that keeps the vehicle stationary by opposing any other external forces. The tractive force is the force that propels the vehicle forward. You can see it with the arrow. It is the one that acts forward, propelling the vehicle by transferring power from the engine to the wheel. We have the rolling resistance, which is the force that opposes the rolling motion of the tires. You can see this as the design of the tire that causes energy loss due to deformation and friction. Having established that, let us now see how these forces determine the movement of the vehicle. For a stationary vehicle, that's a vehicle that is not moving, maybe it is parked, the tractive force must be equal to the frictional force and the rolling resistance. If you can see in this picture, the tractive force is 100 Newton. That is the force that is used to pedal the car, to move the car forward, is 100 Newton. While the frictional force, which is the one opposing the tractive force, is 70 Newton. And the rolling resistance is 30 Newton. If you add that 70 plus 30, it gives you 100. So 100 backwards, 100 forward. Of course, that vehicle is not going to move, because 100 minus 100 will give us 0 Newton. So 0 Newton is not going to move that vehicle to be stationary. If the vehicle is stationary at 100 and 100 newtons forward and backward force, and a driver enters the vehicle and wants to move the vehicle forward, accelerates the vehicle, he has to press his foot on the pedal, which will add to the tractive force. So if we were to add to the tractive force, let's say tractive force increases to 150 newtons, then we have the frictional force at 70 and the rolling resistance at 30 newtons. We see that the vehicle is going to move forward because 150 newtons forward, 70 plus 30, which is 100 newtons backwards. So 150 newtons minus 100 newtons to give us 50 newtons. So we're going to be having a tractive force which will propel the vehicle forward by 50 newtons. That means the driver has added 50 newtons to the tractive force, so the vehicle will move forward.
If we want the vehicle to brake, like the driver should step on the brakes of the vehicle, then the frictional force and the rolling resistance must be equal to the tractive force. So we have to increase frictional force from 70 to 100 and the rolling resistance from 30 to 50. That will only happen when the driver steps on the brake, thereby increasing this frictional force and rolling resistance. So if the frictional force and rolling resistance is now 150 in total, which is 100 plus 50 newtons to give us 150 newtons, and the tractive force forward is 150 newtons. Now 150 newtons minus 150 newtons will give us 0 newtons. That means the vehicle is not going to move. That is how the brakes work, and the brakes is working to stop the vehicle. To reverse the vehicle, once we put the gear on reverse, the tractive force changes and the arrow start pointing backwards, while the arrow of the frictional force, direction of the frictional force and that of the rolling resistance also changes. So the tractive force pointing backwards is showing 150 newtons, while the frictional resistance and the frictional force and the rolling resistance is showing 100 newtons. So the car is going to reverse because 150 newtons minus 100 newtons will give us 50 newtons. So we're going to be having a tractive force of 50 newtons backward. Therefore, the car moves with a tractive force of 50 newtons, but in the reverse direction. With this, I've been able to explain to you how car tires work, how the brakes work by equaling the tractive force and the rolling resistance with the frictional force, and how the car moves forward by increasing the tractive force, as well as how the car reverses by increasing the tractive force in the backward direction, overcoming the frictional force and the rolling resistance. So hit the like button, subscribe button, follow, and give a thumbs up, give us a comment, and every other thing you need to do so that whenever we post a video like this, you will be one of those that will be notified. In the meantime, pause the video and attempt this particular question. Tell us if your answer is A or B in the comment section. Thank you, and see you in our next class.